Hello everyone, welcome to another AP Computer Science video. This video is going to focus on one last topic in relation to arrays. We've seen arrays used to hold lots of different types of data, primitive data, integers, doubles, booleans, it really doesn't matter the kind. We also seen it used with strings, and strings are not primitive even though they are common and the most common class type variable in Java. I do want to kind of emphasize that arrays can hold any data of any type. And it's not just Java pre-existing classes, but classes that we make. So in this example, we'll make a small class that represents something, and then we'll put it in an array, and then we can see that that's accessible just like other objects, except with the only real kind of danger that is not present with primitives is the fact that the references to those objects may be null, meaning they have no connection to RAM, and can cause an exception, particularly called the null pointer exception. So we'll see that in a moment. So we'll go ahead and close some of these previous ones. We'll make a new class. And so for our example, what we're going to do is make a class that represents a bowling ball. So if you've ever been bowling, or if you haven't been bowling balls are very simple tools, or I guess, I don't know what the word would be, items that we use for the sport of bowling. It's a solid polished stone with holes in it. We throw it, and we try to knock down some wooden pins. And so the idea is very simple. And so for our purpose, what we'll say is, well, a bowling ball really has two primary attributes that we care about. The weight, so if you've ever gone bowling, you know that typically you pick a weight that you feel comfortable with so you can throw it, and sometimes people pick lighter ones, some of them pick heavier ones, things like that. And then we'll also say that a bowling ball has a tendency to either curve left, curve right, or go straight. And there's a lot of technical detail to this. The inside of a bowling ball usually has a particular thing called the core, which has a shape, and the shape of the core and the angle of it and the way it's designed may make it more likely to curve one way or faster or in a longer route. But for our purposes, all we care about is maybe having a string that represents, does it lean left, does it lean right, does it go down the center? And that's all we have. We won't worry about the actual mathematics of the bowling ball or anything like that. That's important here. This is purely for an example. So we'll call our class bowling ball. We'll click OK, we'll finish it, and we'll implement our class. And again, we're going to take it very quickly. It's not going to be too much stuff. We'll say our instance variables for this bowling ball are the weight, so we'll say a double for the weight. We will say a string for we'll call it curvature, and so, and we'll say the string represents the word left, center, or sorry, left, straight, or right. We'll make a constructor that accepts the weight, so we'll say double, and we'll say string and again, it's just to store values and instance variables. We'll make some accessors. Okay, and then we'll do one more. And there it is. And we will not make mutators just because we'll kind of follow the real world example that once you produce a bowling ball and you drill the holes and it has a weight and it has a particular core, you can't really change it. The core is on the inside unless you crack it open in half and then reseal it and maybe repolish it. You wouldn't really change one. And I don't know if that's even possible. And of course, and when it comes to the weight, you really can't change the weight too much. Maybe if you shaved it down, but then it maybe wouldn't be regulation size. So again, I don't know all the details of how bowling balls are made. But we'll say, once you have a bowling ball in our system, it does not change. So if you want a new bowling ball, you must construct one. So here we go. Let's go ahead and, with this, let's make one more. Well, actually, let's leave that. I think that's good enough. So let's stick with that for now, and we'll go ahead and try to use it in another example. So now let's make another class, and we will, we'll call it Bowling Alley. So we're the place where we're writing the code that represents the people that actually want to have or manage bowling balls in their system and maybe rent them out or give them to people, because typically you go bowling, you can get a ball for free to play with. And so in our system, what we're going to do in our main is we have to set up, well, how many bowling balls are going to be allowed for us to use or available for our players to take advantage of. And so this is a position where it's a convenient time to make an array. One, because we can maybe ask the user in a program how many bowling balls are you going to make, or we can assume it in some value. We can fill in or randomly create a bunch of different bowling balls of different sizes and curvatures, and then display them in some fashion. So again, this is just purely to get comfortable using an object type as an array value. And again, we've done it with strings, but I want to make sure we're comfortable with our own personally made classes and recognize that those are valid data types. So in this example, I want to make an array of bowling balls. Again, a bowling ball is not a single int. It's not a single string. It's not even a pair of an int and a string. It is an object that happens to contain or is composed of those values. Right? Objects are things in their own in our system. So our array type is going to be of type bowling ball. Right? A bowling ball is a thing, just like a string is a thing, just like an int is a thing. We use our bracket notation to represent an array instead of a single value, and we'll call it stock. So this represents the bowling balls that we have available to us for our alley. And let's go ahead and initialize it, and we'll just start off with some small number, and then we could generalize this to be any amount we want. But let's go ahead and say we want a new array of bowling balls that maybe we have 10 of. So our alley has 10 balls that are available to use, and people can use them. But now we have to recognize, and this is where it becomes different for arrays of objects. Primitive arrays by default, or arrays of primitive types, default values to something. So integers to 0, doubles to 0.0, booleans to false. Class types like strings and bowling ball do not have a default value. Instead, their content, those spots in the array, point to nothing in RAM, which is the null value. And that's fine because it means there's no content, but it's dangerous because if we try to access that content and use it in some fashion, then we will crash our program. And so I'll give an example right here. Perhaps we want to, we'll go ahead and finish it up. Let's say we're going to print out the content of our stock, display it. So let's do it with a regular loop. So we'll say for int I equal to 0. So we start at the first index of our array. And while I is less than the length of our array, strictly, it's typical going through an entire array, up by 1 each time. Let's print out a nice little, we'll say bowling ball, we'll say the weight, and we'll say the curve so that we can know what bowling balls are available. So we'll say, let's retrieve a bowling ball, the current bowling ball, the ith one. So we can say, and this part is not necessary, but it is helpful to separate. So bowling ball curve is equal to the ith bowling ball, so stock at I. So now cur refers to the same value that stock at I would refer to if a bowling ball exists there. And then from here we can do something like, let's print out a nice little message. We'll say bowling ball, and I'll just put some lines, 1, 2, 3, 4, 5, 6, 7, 8. Let's do something like that. And then we'll print out the weight. So we'll say weight. And we'll attach the weight of the bowling ball. How do we access the weight? We wrote an accessor method. So we can say cur.getWeight. And of course, I made cur temporarily just to refer to it. I could have said stock at I dot get current weight, because this refers to the same bowling ball. These two variables now are kind of matching up. They point to the same location in RAM, and so we have two different ways to access. We typically make the variable so it's easy to write methods like this. And then similarly, let's go ahead and print out our curvature. So we'll say curvature. And we'll attach the current bowling balls get curvature. And then we'll print out an empty line just so they're not all crammed on top of each other. Now, this is simple enough, but the problem that we may have, that we're going to have, that we are not maybe recognizing, is that this array was not, the array was constructed, so the variable points to a location in RAM where there are 10 spots. But each of those spots are objects themselves, and if they have not been initialized to actual objects, and remember, to make an object, if it's not a string, you're going to have to call a constructor. So new something. Nowhere in this code have we said new bowling ball. So no bowling balls actually exist. In fact, I don't know if what this warning is. Let's see. Let's see if it gives me what this warning says. Oh no, that's just trying to be fancy, and we can do that in a moment. That's something else I was going to do. But there are no bowling balls, and so if we run this, we're going to get a very particular exception, and this is a huge problem. So let's go ahead and try to run it and see what happens. And unfortunately, this is a semantic error. In terms of syntax, we've done nothing wrong. But when we run our program, it begins. So it runs, it compiles. Notice the first sprint works perfectly fine because there was no access of any objects. So the loop itself works, the array exists. but the content does not. And here's the error: null pointer exception, right? The array contains null values. Arrows or addresses, there's no actual address. So if we had an address book with things, it's just if we had blank pages. And of course, if you try to go to a blank page, it doesn't work and it crashes and it fails. And so immediately in the first one, it fails. So what we have to do is, making the array is not enough. We must fill in each spot of the array. And again, with primitives, it's not a consideration. The default values are filled in for us, right? 0 is an integer, so that's why there's not an issue. 0.0 is an integer. False is a Boolean. For class types, there is no default behavior typically, and therefore we have null as our value. And that's a huge problem. And as we get into more complex uses of classes referring to other classes and classes accessing other classes, null pointer exceptions are very common. And thankfully, NetBeans in particular kind of gives us a hint typically in what's called the stack trace. So here's kind of telling us where it failed. But right here it says, well, you know what, this crashed on line 14. And what it tells us is, well, you tried to call getWeight from an object, but that wasn't really there. So cur may have been a reference to an object, but in reality, when the program ran, it wasn't, and therefore it crashed. So we need to come up with a system to make sure that these spots in the array are not empty. So let's go ahead and do that. Let's go ahead and say, you know what? Let's create assign. Right, so we have to create and assign random bowling balls. And so what we could do is we could fill in these, but you know what maybe we should do is change this number to a variable. That way we can refer to it in multiple occasions. So let's do this. Let's say int ball count is equal to 10, and then now we can refer to a ball count here. And again, that's just to make it easier because we're going to do that to loop how many times we want to create it. So let's make ball count bowling balls, whatever number that is, 10, 5, 100, you know, any number. So here we go. So we're gonna do it in multiple steps. So we'll say step 1, random weight between, let's say between 6 and 20 pounds. I think most bowling balls are somewhere in that range. I don't think too many people go under and too many people go over that weight. It's pretty uncommon. And then we'll say a random curve direction. And so that one's a little bit harder, so we'll talk about in a moment how we can make that happen. And then the next step is assign the, or we'll say construct the ball from the random values. And then 4, assign the ball to an array position. And this is our strategy. Pick a random weight, pick a random curvature, create a bowling ball in RAM, assign that bowling ball's RAM reference to the array in one of the spots, and then we continue to do this. And once we have all 10 spots filled, or all ball count spots filled, we have created our bowling balls, and then this code will work without null pointer exceptions. So here we go. We'll start off I at 0, I is less than ball count, I plus plus. Because if ball count is 10, from 0 to 10, not including 10, is 0 to 9, which is 10 times. You could have said from 1 to less than or equal to ball count. That's acceptable, as long as it iterates ball count times. So let's create a random number between 6 and 20. Right? So if you want to, pause the video and come up with this algorithm yourself. We've done this before. We should hopefully know random numbers. And then we will try it out. So hopefully you figured out how to make a random number between 6 and 20 pounds, and let's go ahead and do that. We'll say double, we'll call it WGH, or GT, and we'll say the weight is equal to, and, oh, I'm sorry, I meant to, let's make it an int. It really doesn't matter. Because I don't think we necessarily have 7.5 pounds. We'll say between 6 and 20 pounds, whole numbers, because we don't want strange fractions. So it's to save ourselves the effort. I don't necessarily want a bowling ball that weighs 6.15972 pounds. We'll just say whole number weights, and then when we store it as a double, it gets converted back to a double, which is fine. So we'll say the weight is equal to the math.random. Here's the important part. And since we want to start at 6 and end at 20, we're going to say times 15 plus 6. And again, if you're not sure why that's the case, let's validate it. And again, to validate a random number range, we can always find the lower bound of our mathematics and then find the upper bound for mathematics. And if they match what we wanted, then we know we can get any number between them. So let's see if we can get the lower bound, 6. In the case of the lower bound, we can pretend that random gave us 0, which is a possibility. 0 times 15 is 0. 0 plus 6 is 6. This is as a double. 6 as a double cast to an int is 6. Our lower bound is 6. So that seems correct. Now the upper bound. Math.random, the upper bound that the highest number can give us is 0.999 repeating. 0.99 repeating times 15 is 14.999 repeating. 14.99 repeating plus 6 is 20.99 repeating. 20.999 repeating cast to an int is 20 because truncation occurs. So the 0.9 repeating is just chopped off. We end up with 20. 20 stores. The upper bound is met. Therefore, this mathematics gives us any number in that range as an integer. So we can get 6, 7, 8, 9, 10, all the way up to 20. So there's our random weight. Now, to make a random string, that's going to be much more complicated. So instead of making a random string, we know there are 3 options: left, straight, or right. So let's just pick a random number between 0 and 3 and ask if it's a 0, then make it left, and if it's a 1, or make it a straight, and if it's a 2, make it a right, or any combination of those. It doesn't really matter. So let's try doing that. So we'll say int c is equal to int math.random times 3. And again, because it is not inclusive, this will go from 0 to 2.99 repeating, and that casts to int, so it'll be from 0 to 2, which is 0, 1, and 2. That's 3 options. And now we can safely say if c is equal to 0, then we'll say, let's go ahead and make let's do this. We'll say string curve is nothing, and then we'll say if it's equal to 0, we'll say curve is equal to left, else if c is equal to 1, we'll say curve is equal to right, and we'll say else, so if it's a 2, curve is equal to straight. And so there it is. So the ball can either curve left or curve right or go straight when it's thrown typically. And then now that we have those 2 values, so now we have a weight, which can be cast to a double, so there's not really a problem, and a string, we can construct the bowling ball, step 3. So how do we construct an object? We make a variable of the type, and we assign it a new call to the constructor, and then we have access to a bowling ball. So let's do that. Let's say bowling ball, we'll call it B, is equal to a new bowling ball. And again, I'm using the constructor. I need to know this constructor accepts a double and a string. So WGHT, which is an int, but we'll cast to a double without any problems. And then, of course, curve, which is a string. So we've random weight, a random curve. We construct a bowling ball. And now step 4, assign the ball to an array position. Thankfully, I is conveniently mapped to 0 to 9, which is ball count. And that's another reason why I started at 0 and did less than ball count, because it matches with the array indices in a convenient manner. So we can say stock at I is equal to the bowling ball we just created. So notice that all these variables are local to the loop, which means they all get created and destroyed each iteration. The only thing that exists long term is stock at I. And because stock at I refers to B before the loop is over, we have a copy of the address of that bowling ball, so therefore all 10 bowling balls are remembered. And now, if we run this, we should see 10 bowling balls. This code now is correctly effective. It was always syntactically correct, but now it's semantically correct, meaning it makes sense because there are no blank spots in the array. So let's go and run it. And there it is. The first bowling ball was weight 15 in a straight curve. The next one was 8 pounds and curve to the right. The next one was 18 and curve to the right, and so on. So we can hopefully see a left somewhere. There it is, 12 pounds and left. So we've covered all scenarios in a variety of different weights. Now if I run it again, just to make sure it is different, and there we go. 11 in straight, 13 in straight, 14 in straight. And then again, proof, arbitrarily large sizes. Let's make only 5 bowling balls. And there they are. 1, 2, 3, 4, 5. So lots of control. We can play with this, and again, we could take this number and ask a user from it with the scanner. We could get it from a file. We could generate a random number. I mean, there's an endless supply of ways we can set this program up now. But the idea is that the array expands based on that number and has the correct size. We construct as many as we need based on that size, and we access all of them with that size. Right. So the only real difference between primitive and class type variables is how we assign the values. You might have to construct an object before you can assign it, as opposed to a primitive where you can just assign it a literal value. That's or a mathematics. Unfortunately, classes objects do require a little bit more effort on our part, but they're worth it because in reality, if you think about it, we've actually stored 2 pieces of information per bowling ball: a weight and a curvature. And if we made a bowling ball more complex, this would still work. This tester would not have any impact on it. A bowling ball could be as complex or simple as we want, and it all still works. The final thing we'll do now is just to maybe make this a little bit nicer, is practice our enhanced for loops or for each loop. And I would say this is a perfect example where using a regular for loop, we could probably change it to an enhanced for loop because there's no need. If we look at this code for the printing of the bowling balls, the only time we use I, the sentinel value, is a single time as a reference into an index. For each loops, say, we will do it for you, make a temporary variable, and you can access the object or the value directly. And in fact, what we did here won't change at all except for this one line and for this line. And these will kind of be merged into one single thing. So let's try doing this. I'm going to go and comment this out. And I won't need this one anymore either. And the combination is an enhanced for loop. We'll say for. An enhanced for loop says for variable of particular type in particular collection. So our type, what data is in our collection, bowling ball objects. The name, since I already have it kind of used here, we'll call it cur again. This is one of the few times we used a colon. So an enhanced for loop uses a colon. And then the name of our collection or array in this example is stock. And there it is. No difference. Runs the same random output. Here in this case is 5. And it goes through all of them, right? Because we went through all of them. That was our goal. We didn't skip any. We didn't go backwards. And we only used the sentinel to get a value. And so, in fact, this is done for us all compacted into one nice short version. So an enhanced for loop is a great usage here. Saves us a little bit of writing. And there it is. So for every bowling ball called cur in stock, do this work. Print out the weight and the curvature. Repeat the process again and again. So I hope we see that really arrays are just an extremely powerful tool in Java. The ability to keep multiple pieces of data that are related to one another in some significant fashion is a big deal. And the kind of burden on us as programmers is to be comfortable with iteration. To manage multiple pieces of data, we must iterate over that data. And if we can do that effectively, we have expanded what our programs can do. We no longer have to make assumptions, or the assumptions that we do make are much more localized and less weighty, I guess, in our decisions. And so we have a lot more flexibility, and our programs can be much more robust when designing things. So I'll see you in the next video very soon.